Okay, class. So you're probably watching this video after our significant figures explanations and rules. So this is also an opportunity for me to kind of revisit rounding. A lot of times you'll punch in calculations or you'll see numbers and there's extra numbers in there, and we only need so many significant figures and only need to write so many numbers. So this is a good practice on how to determine when we have more than what we need to put it in the correct number of significant figures. So for this first problem, they want us to have only 3 sig figs. So I would go 1, 2, 3 numbers, 3 sig figs. I would stop at the tens place. Now, if I look to the right of the tens place, that number is 4 or less than 4. So I would just drop that number and write 68.3. Now, if I go to this particular example, they want 2 sig figs. I have to remember that these are leading zeros and those never count. So the ones to the left never count and they're only used for placement value. Okay? So I go here, and this 9, that's 1 sig fig. I need one more. If I go one more over, right, these are trailing zeros, okay? And they count. Why? Because there's a decimal point. So I only need one of them, though, because I have the 9. So to have 2 sig figs, I would write 0.090. And the 2 sig figs are the 9 and this trailing 0. And that trailing 0 counts because of that decimal point right there. If I go to the next number, I need 4 sig figs. So 1, 2, 3, 4, right? And if I look, that 7 is actually 5 or bigger, so I would round up. This number would be an 87.26. Here I want 3 sig figs. So 1, 2, 3. This right here counts. Why? It's captive. So how would I write this out? I would still need to write placement value here. So I would use trailing zeros, but without a decimal. So I could write this as 10200, which really is 10,200. Okay? That would give me 3 sig figs. These trailing do not count because there's no decimal. Okay, this trailing is captive and it counts. Okay, now if I wanted to put this in scientific notation, I could have also done that because I could have gone 1, 2, 3, 4, and I could put this number as 1.02 times 10 to the 4. And again, that captive 0 counts. 2 sig figs here. These do not count because they're leading. So 1, 2, it's a 9. I'm going to round up, so this would be 0.064. I want 3 sig figs here. Now this is tricky. 1, 2, 3. The captive 0 counts. I go here, and I would have to round up, right? So if I round up, what would that be? It'd be 102,000. 0, 0, 0. Now, if I want to put that in scientific notation, I can. It'd be 1.02 times 10 to the 5th. Oops, let me go back and finish that last slide. 2 sig figs, 3,800. Why? Because right there, the 6 is greater than 5. I'm going to round up. 1 sig fig, so that brings me here. It's a 9. I'd have to round up. Right? So what does that give me? 100. These trailing zeros don't count. Because why? Well, there's no decimal. Now, if I made the mistake and I write 100 with a decimal, this would equal 3 sig figs. So be careful. When you have trailing zeros, 1 sig fig, just leave those zeros for placement value. Now for the next exercise, how many significant figures in what I have? Okay, So a lot of people might make the mistake, oh, there's only one because of that one. But remember, all of these trailing zeros, they're going to be significant in count. Why? There's a decimal. So I actually have 6 sig figs here. Now if I go over to this problem, these two non-zero digits count, but what about this trailing zero? There's no decimal. No decimal doesn't count. 2 sig figs. What about this? Trailing zero, but there's a decimal. 3 sig figs. These don't count. Why? They're leading. However, this trailing does. Why? There's a decimal. 2 sig figs. Now, if I want to express these in scientific notation, this is tricky. Again, these leadings never count. Well, what about this captive and this trailing? The captive counts, and this trailing counts because there's a decimal. So guess what? You have to write that in scientific notation. So how would we do this? 1, 2, 3, 4. It's less than 1. We moved it to the right. It's a negative exponent, but we're going to write all the significant figures. So it's 1.0320. Yes, we have to write those, times 10 to the negative 4. What about this? Right? These are trailing, but there's no decimal, so they don't count. We don't need to write them. So this would just be 1.2 times 10 to the 3. These trailing zeros aren't written. They're not significant. Why? There's no decimal. So what about here? Right there, that's a captive. These trailing do not count. There's no decimal. So how would I write this? 1, 2, 3, 4, 5. So I moved 5 to the left. It's bigger than 1. So the 5 exponent is going to be positive. It's going to be a 2.201 times 10 to the positive 5. I write the captive 0 because it's significant, but not the trailing. Last but not least, all these leading don't count. Their placement value, 1, 2, 3, 4, 5. It's a 1.2 times 10 to the negative 5. So I hope this helps. I hope it made a lot of sense to you. If you have any questions, go ahead and leave them in the comments section, or you can send me an email. And I want to thank you again for listening and taking the time to watch this video.